So in order to begin today's session, we will go with the session name first of all, which is how are programming languages designed in the aspect of um, the semantics and the structure, right? So going ahead with the session, first of all, let's try to understand whether if a human is given some sentence and if he has to understand on his own, then on what all aspects does he focus and how does he understand very easily, right? Yeah. So if you have thought so till now, it's fine. If we consider how does he relate things and how does he recollect things, how does he understand very easily, then it's all about our context. How well do we understand it? Context, like how do we relate things? And the next one comes the memory, like what do you store after understanding everything and all. And then next comes the way of recollecting. How do we recollect them? How do you connect the words with the each other, and how do you frame a new sentence if you want to express or convey something, right? In that sense, if a machine has to exactly convey or express some content, then how does it do? That is all done using programming languages, right? So let's deep dive into the today's session, that is how do programming languages how
Yeah,
the programming languages actually are designed and based on semantics and structure. The first, look at the slide, the blueprint of programming, like translating human intent into machine execution. Like, might be a human sitting on the desktop and trying to share his intentions, share his information with the desktop, and trying to gather some more content through the desktop, right? Then how does it happen? How does it begin, right? We'll understand it with the next slide. Please move to the next slide, Pawan. Yeah. Now try to compare the things. How do they work actually? Having a human, as I told earlier, he might understand it through context. He might understand it through memory. He might understand it through many other ways. But how does it happen with a robot? Does it have a memory as like we have, right? It might have CPU and all, but does it relate on its own? Does it have the context in its mind? Now having AI coming up in the era, might be it utilizes AI and recollects things and relates them as ever needed. But in the earlier days, where it was just an introduction to the programming languages, just try to understand how do the things happen. Now let's talk about it. The little robot problem. In the first picture, as you can see, when a person orders a robot to prepare a sandwich, then the robot has to initially understand what are the requirements, right? Is it a bread loaf or a peanut butter bar or what? And then it has to understand the procedure, how do we prepare and things and all. It has to begin preparing, right? So the basic machine requirements should be, it has to be first of all unambiguous, right? Only one possible interpretation, like having multiple parts in order to prepare any content or any dish or something to be eaten. Then it has to choose some path and has to begin with that path, continue on that path, putting all the efforts and all. So it does choose any one path, that is one possible interpretation, and also it has to be precise. That means it has to be clear what should be done and what not to be done. So in this case, the precision, that is precise, might be zero or sometimes working upon some conditions, right? And then comes to the execution. Having thought something in the mind, then how does it execute? It does it physically, that is capable of running on hardware. And then predictions, it also has to understand what happens if what happens is if something else is executed, and what happens if something right one is executed, and it has to predict actually what happens, right? In that case, the same input always yields the same exact behavior, right? Whatever is implemented, according to that he might look at the results what he receives. So humans rely on heavy context, metaphors, and assume knowledge, but machines do not. Machines do not have the capability as it have. I mean, as it has AI right now. Let's move ahead. So the main components or the main parts of the languages through which machines would understand earlier were the syntax and semantics. What do you mean by semantics? What do you mean by syntax? How are they different? Let's try to understand that much more clearly. The syntax is nothing but a skeleton of a human body, and a semantics is nothing but the skin or the way the sense organs are utilized by the human body in order to understand, in order to see, in order to smell or something else. In that sense, even for a robot, the syntax is structure, or even for a machine, the syntax is a structure, like how it is coded, how is it happening, like step by step and all. That is all about structure. Example, what we can see here, a colorless green ideas sleep furiously, like having a painting, but it is not actually colored. It is not painted actually with colors. Then what does it look like? It is just like a normal plain notebook, right? A plain page, having done something with a pencil, but not colorful at all. Then do you think someone attracts to it? Not right? Right. So it is grammatically perfect, but practically nonsensical. So what has to be done in order to turn that painting into very much attractive, very much comfortable and very convenient to be visible, right? Then in that sense, it has to be colored. That means the semantics rule, that is, a meaning has to be delivered to the painting so that upon looking at the painting, we directly understand what it is trying to convey and all, the real world consequence and behavior of the structure. Having done a plain painting with a pencil but not colored, if you don't add any color, then it's totally of meaningless and nonsensical. So in that case, we add color. That means in technical words, we add semantics to it. Try to understand if there is an example x is equals to 5 in the double quotes and plus 3, then how is it understood by different languages? Syntax. Try to understand valid variable assignment and operational usage. That is the syntax. And semantics. Suppose you try to understand or code the language, code the statement in JavaScript language, then it finally evaluates to 53, not 8 exactly, right? That is according to the semantics it is using, the syntax it is using. So in that case, there are specific programming languages for specific purposes, depending on specific requirements. Let's try to understand them going ahead. Yeah. First of all, let's understand something. If it is delivered, something is delivered to the machine, and how does it understand clearly? In that process, the first one is the text that we have shared with the machine is first broken into tokens, right? It has to understand what every word means exactly, what every word is conveying, right? In that sense, the text is broken into tokens, and then each word is parsed exactly. A parser is utilized in order to parse, and then it is taken forward through the interpreter or compiler, where it is actually converted into machine code, and then it turns and gives out the result that is very comfortable for any human to understand. So there comes the interpreter or compiler, and then the after the machine code comes out through the interpreter or compiler, then that is very much comfortable for any human to understand, as I said earlier. So every language, whether Python, C++, or JavaScript, relies on this foundation system architecture to convert dead text into live action. Suppose the text might be in English, then as we know earlier, the computer understands only through binary language, that is zeros or ones. But if it is through a programming language, then it has to be turned into tokens, parsed, and then gone through interpreter or compiler, and then it is very human understandable. Let's move ahead. Lexical analysis. What we have discussed is the first process in how is an sentence or how is a statement easily understood by the machine by converting them into machine code, right? So suppose we have an if statement x is greater than 5, Then it is broken into smaller tokens like if parenthesis x greater than 5. They are broken into different tokens. So computers cannot read sentences. They can only process categorized words. That means the words are the tokens here. So they categorize and process them in order to understand, in order to read them, and also try to understand white space and comments that are included into the statement. They are nowhere considered. They are typically discarded at the stage on the factory floor itself. That means there is no use of having a white space and comments until and unless that is only for understanding, for the human, in order to understand by himself what code he is writing and all. In that sense, white space and comments are clearly meaningful rather than writing into the code and machine doesn't understand them at all, doesn't even care about them. Let's move ahead. Parsing and the AST. This is the second process. What is happening for a machine to understand the statement or the human understandable language and or code, whatever you say, uh, to understand them. This is the second process, parsing and the AST. After the statement is broken into simple and similar tokens, they are going through the parsing. That is, each word is actually cared and looked into. So you can go through the image over there, the problem state, 5 plus 3 into 2. It is simply understood by breaking them and dividing them into hierarchical structure. Hierarchical in the sense a tree-like structure. Because in order to understand a complete statement, first of all, they have to be broken into tokens, and upon priority, the words are chosen, and according to the sequence, they are understood. You can also read out here, tokens are a flat list, but logic requires hierarchy, right? Tokens are flat list. Tokens are completely visible, and in order to understand them, a logic is definitely required. And logic requires hierarchy. And depending on the logic, we gain the understanding also. Parsing enforces grammar rules, like math precedence by building an abstract syntax tree. Suppose we have gone into suppose we are getting into our childhood and we are taught about BODMAS rule, right? Bracket of division, multiplication, addition, subtraction. It states that suppose we have a mathematical operation or a mathematical statement, then if we are willing to solve it, then it is definitely to be done on BODMAS rule. In the same way, that is a logic for solving the problem, and this is a logic in a computer or in a machine code to be followed. Right? Multiplication is placed lower in the tree, so it executes before addition, yielding the correct answer. Let's move ahead. Evaluation timing. Static versus dynamic semantics. No matter if we are trying to understand a code and if a machine is trying to understand the code, whatever you have written, and it has to also throw out the output, right? So in that sense, they are mainly going through compile time and runtime. So let's try to understand what is compile time and what is runtime. Suppose we have written some code in Python, and it gradually goes through the compile time first and then through the runtime. Right? Compile time is what? Compile time is it is done during mm, during the duration while we are building the code actually, in order to follow the structure and build the code very efficiently. Suppose try to understand why the structure is very much important here, because suppose we are trying to solve a problem and it could be done in two ways. That is something very straightforward and something very indirect, right? So that structure is very important and playing a very crucial role. So in that case, building the code is very much important, as well building it efficiently and with a structure is much more important. So there comes, and that plays the role of compile time and compiling actually. So it's like the inspection, check before the program ever runs, enforces type safety, scope rules, and syntax validity. So why is the compilation done? Compilation is done in order to check the safety, the scope rules, and syntax validity. whether everything is fine with the code, it is allowed to the move to the runtime or not. And what about runtime? It is a drive, the actual runtime behavior. Like after the code is built, it has to be executed. So for the execution, the runtime actually plays a key role. The actual runtime behavior handles value evaluation, memory allocation, and uncovers out-of-bound errors. Suppose the code is executed and might be the memory is already occupied and we do not receive the desired outputs. Right. That is one of the problem. On also might be something where something or somewhere like in the statement you see a number is divided by zero, right? Then that is totally of useless, and those all mistakes or those all errors are being detected in the runtime, so that if we correct the errors and then code moves smoothly and we get the desired output. Please move ahead on. The semantic gap when languages misbehave, right? So imagine we have written a right code, but we are not following the syntax at all, and we are not following the language rules at all, right? And then it's of no use, however, whatever you are willing to convey. Try to understand, code doesn't exactly what the language designer dictated, not what the programmer intended, right? Code does exactly what the language designer dictated, not what the programmer intended. Like whoever has developed the code, then that I mean that specific rules have to be followed in order to write a proper efficient code and to be executed also, right? So that is the actual sense of the slide actually. Please move ahead, Pawan. The typing trade-off, safety versus flexibility. So let's try to understand on categorizing different languages, right? Java, C++, and Rust language, they all fall under static typing, and Python, JS, Ruby, they all fall under dynamic typing. Let's try to understand why do they fall under static typing. Because we are facing any errors during writing the code Java in Java, C++, or Rust, then they directly shift the errors to compile time, right? And increases execution speed and system safety, sacrifices developer flexibility, requires verbose annotations. But coming to Python, JS, and Ruby, they shift the errors to runtime directly, maximizes rapid prototyping and flexibility, relies, relies heavily on runtime checks and developer return test. Turning the dial represents deliberate architectural trade-offs, not a search for perfect language. Please move ahead on. And the physics of execution, AOT, JIT, and interpreted. Through this slide, let's try to understand on the basis of peak performance and startup time, how are different languages classified, right? The Python language having many versions coming up in the yeah having many versions coming up. The Python is rated to be the number one, that is it has very low startup time and also it provides good performance, right? And then comes up the Java in the line where it provides a bit low startup time but provides a good performance also. And then comes C and Rust language. It is slowest to the compile, but it has blazing execution. That means the execution works out such efficiently that you might wonder why is it so different to Python and Java, right? High frequency trading demands AOT compilation. Now, what do you mean by AOT here, right? Try to understand that AOT compilation, data science scripts demand interpreted speed of thought. Web browsers rely on JIT engines to balance both, right? Yeah, please go ahead, Pawan. Yeah, as I told about AOT earlier, it is explaining ahead of time, and JIT is nothing but just just in time, yeah, just in time compilation. And then coming to mental models, that is imperative versus declarative. Now suppose you are writing the code and it has to execute and provide us a desired result. then how does it happen? How is the computation happening? Definitely, it happens step by step, right? If you are writing a set of code or a code of some 10 or 150 lines, even it might be a lower time, I mean, a lower lines having only 10 lines, and even it might be 150 lines. So, how does it compute in the machine? It definitely happens step by step, right? So, it focuses on step by step state changes, loops, and mutable data. Coming to the languages, you might consider Java, C++, or even it might be any language, any written programming language. It definitely happens step by step. But try to understand the declarative mode. That is, we were using HTML, CSS, JavaScript, and also React.js, AngularJS, and all. They are all falling under declarative. Why? Why do they fall into declarative? Because you are imagining what has to be delivered at the last, and you are writing the code so that you get the desired one. Try to understand. The developer describes the desired result. The underlying system determines the control flow to achieve it. Right. Even SQL and Haskell fall under the same category, that you're writing the code and you'll definitely find an desired output. Like suppose you're writing the code to get a front end page of a delivery website. Then you write the code accordingly, and where errors might come up, but that is totally visible, and also minimal errors, and they don't make any minimal impact also. I mean, they don't make any huge impact also upon the front end what you're making up. But at final, you get the desired output, and that is what about declarative. Please move ahead, Pawan. The greatest vulnerability, that is managing memory. It's very different for each and every language on how do they manage memory. The first one is manual, right? Coming to C and C++ languages, it is very different. How do they actually manage the storage? Here it's done completely manually, right? It has maximum performance and control and highest risk of use after free vulnerabilities and memory leaks, right? In the sense, here coming to C and C++, a memory is allotted manually whenever required, and also it is freed whenever required. So it is done all on a under manual intervention. But coming to Java or Python, it is kind of automatically done as well manageable. Here we are including garbage collection, right? Automatic memory tracing and highly secure, but introduces performance overhead and unpredictable past times. But now coming to Rust, it's all about on us. The ownership is completely upon us, and compiler enforced single owner per value, mathematically memory safe, zero GC overhead, but features the steepest developer learning curve, which is quite comfortable for any developers to utilize, but depends on the requirement what you have to satisfy. Please move ahead, Pawan. The architect's power, building mini lang. Suppose having deal with all the languages whatever they are available in the market or industry, now we are trying to build any language on your own, then you will have to consider the lecture, the parser, and the evaluator. These are the major components which have to be understood, and the language or whatever you are building have to be undergone through these three components. So try to understand the key insights. Languages are not magic; they are just pipelines, so that the operations could be performed. By combining a lexer, an AST parser, and an evaluator, you can build a custom domain-specific language in under 100 lines of code, used in industry for custom business rules, configuration engines, and specialized query languages. So try to understand, if any language has to be developed, then you will have to have a sight upon lexer, parser, evaluator, whether the language you are developing is quite comfortable with them or not. If they are totally irrelative, then it's of no use, like how far or however the complex or smooth language you are building. Please move ahead. Right. We will try to understand which language is best at which moment, for what requirement, and for what purpose. the language C. It is better when it is when it requires a manual memory management, and it is also better at static typing system, and AOT execution is when implemented, and it is best for embedded systems and all. But coming to Python, it has a garbage collection based of memory management, and it also delivers dynamic typing system, right? And it has interpreted execution, and it is best for data and scripting. Like nowadays, you might see Python is the best language used for AML tasks, core AI tasks, and all. The next comes JavaScript. It also utilizes garbage collection methodology of memory management. It also inhibits dynamic typing system and makes use of JIT, just-in-time execution, and it is best for web and UI development. Right? If you are willing to develop any website, then definitely there would be a key role of JavaScript. Consider React.js, AngularJS, and all, which are the modules falling under JavaScript. And then comes Rust. Rust utilizes the ownership model. That is, it's upon the developer how much memory is required and all, how and what he chooses. Right? It inhibits static typing system where it utilizes AOT execution. Right? And then it is best for security critical and high performance task and all operations or whatever you call it. The major insight is that there is no best language, only the correct architectural trade-off for the specific system requirements. That means it is only on you whether which language you choose, on what requirement you have, on what purpose you are trying to satisfy. Please move ahead, Pawan. Yeah, the blueprint, that is an overview of all what we have discussed till now. That syntax is very much important, and semantics is also important. No way it is that we are minimizing the importance of some syntax or semantics, but all are equally important, but depends on what requirement you are looking at. Right? The syntax is structure. As I told earlier, the syntax is the skeleton of a human body, and syntax is for a machine. The lexer and parser turn raw characters into an organized ASL tree. Right? As I told earlier, the suppose you have a statement consisting of the numbers, and you will have to solve the statement, numerical statement. Then that numerical statement, suppose it might be 3 plus 2 into 1. Then we draw a tree structure, right? You'll definitely write the operator first, and then below the operator you'll write 3 and 2, and below that you will add multiplication operator because it is the lowest priority, and then falls 2 into 1. In that way, we are trying to solve the problem and make a result. And then coming to semantics. Semantics is meaning. Like whatever you have developed, suppose it's coming to human language or even a human sense. A semantics is nothing but adding the skin, adding all sense organs to it, so that an operation or any operation could be performed, something like vision and audio and all. So similarly, for any machine, semantics is kind of a meaning. Static checks inspect the code, dynamic execution drives it. Design is trade-offs. Every language compromises between developer flexibility and machine performance. Right? It definitely falls between developer flexibility and machine performance. You will have to choose what you are willing to, what required, and what satisfies. Final takeaway: programming languages are artificial bridges. You're not just writing code; you are operating a carefully designed translation machine. So I would like to suggest you to choose a language based on your requirement and purpose. Definitely, you will be doing good.